Okay, good morning, everybody. Again, I think we're recording now, and welcome to week 3 of Math 174, Numerical Analysis 1. And as I was saying during the pre-lecture, um, any reactions or comments about Lab Extra 1? Masyado bang mahaba? Masyado bang matrabaho? Nahirapan ba kayo or what? Talagang ayaw
Ano,
nyo mag-comment, sige.
may
Hahabaan
cer
ko pa yung next excerpt.
may
Yes,
ano
how's
sir,
that?
may certain items lang po na parang yun nga po yung tulad ng sabi niyo kanina kailangan maidagdag sa code, yung mag-manipulate,
Uh-huh.
gano'n. Siguro dun lang po kami medyo napaisip talaga. Especially po 'pag Matlab po yung ginamit, gano'n. Kaya nag-search ako po dun sa ibang item, parang nag-search po ako ng, ibang code na ilalagay dun sa may binigay niyo na po para masagot po yung ibang items.
Mhm. Oh, that's great, Neil. Yeah, yun talaga yung yun talaga yung purpose ng lab exercise. I won't give you everything. Pero isa sa mga bagay, I like what you said that you had to search for something, Kasi hindi ko sa inyo i-feed lahat ng kailangan niya sa programming. I can give you the details about the numerical methods itself, Pero yung extracurricular or yung mga over those things, kailangan nyo siyang i-search. And one thing about Matlab is ang ganda nung kanyang help function. Kasi pwede mo siyang uh, mag-search ka lang dun sa help window o kahit sa internet, sa MathWorks. So, lagay mo how to make a scatter plot. So, andali kasi meron siyang dun sa documentation page, meron dong examples that you can copy paste into your MATLAB window, tapos irarun mo na siya and you can play with it. Probably nakakapanibago lalo na kung ngayon lang kayo gagawa kasi ganoon naman talaga. Nagbabasa ako kahapon ng ilang books about teaching and learning, no? Ang sabi ay it really takes time for something to become automatic, especially if it's a new concept. It really needs time. Kasi meron tayong dalawang, ayan, nagkwento na naman ako outside the scope. Meron tayong long-term saka short-term memory na nagdedetermine ng cognitive workload natin. And these new things that we are learning, pumupunta muna siya sa short-term memory, which is like the RAM of your computers. Limited yan, 16 gig. Hindi ko lang alam sa ating memory, sa ating minds kung gaano siya kalaki. Pero doon muna siya pinaprocess. And for it to become automatic for us, dapat ma-assimilate siya or ma-accommodate siya ng long-term memory, and that process takes time. So don't worry kung medyo tagal lang kayo this time, then that's fine. There's a learning curve to it, and hopefully as we go along, you become more familiar with it. Ganyan din yung mga estudyante ko from last semester or from last year. Pero nung nag 175 na sila, medyo smooth sailing na. All right? And then another thing is that wag niyong itatapon yung mga programs niyo na ginagawa. Sometimes we'll just build over them as we develop more complicated methods. So, lagi akong bumabalik dun sa mga lumang exercises or lumang programs. And probably in the problem set, you'll need to use your Lagrange program para sagutin yung nasa problem set. Ganun din, Unit 2, Unit 3, even sa 175, gagamitin niyo pa rin sila. So don't ano ba sa English na manghinayang? Huwag kayong manghinayang, Tagalog na nga lang. Huwag kayong manghinayang dun sa efforts na gagawin nyo about MATLAB because that will really pay off, right? Then I'm seeing something on the chat. Mhm. Hindi entirely sure kung tama yung ginagawa ko. Yeah, we always feel that. Lalo na kung bagong topics, medyo naninibago. Okay, that's fine. Pag-extract ng data from Excel, medyo natagalan. Oh yeah, that's also one of the difficulties I had. Pero ang ginawa ko ay ganito. Meron ako sa Excel, dinownload ko yung dates, kasi nagawa rin ako ng answer key. Tapos, di ba, kailangan ko malaman yung day number. So, kay Excel, meron dong, tawag meron dong function that counts the number of days. So, equals days, parentheses, yung end date, comma, yung starting date. Pero kailangan mo mag-plus 1 kasi halimbawa yung January 1, yun yung day 0 niya or something like that. So, you need to adjust. Tapos, din magkakaroon na siya ng isang column. Ang ginawa ko, di ba, kailangan niyo ng vector t, ng row vector t para dun sa MATLAB code. Ginawa ko, kinapi-paste ko lang yung Excel, yung nandun sa Excel, yung column ng day number. Tapos, pag pinaste ko siya kay Matlab, nakita ko ay naka-ano pa rin siya, naka-column, parang naka-enter. So, meron ka isang number, halimbawa, number 3 yung unang entry, tapos ang susunod halimbawa ay 4. Pag kinapi-paste ko siya kay Matlab 3, tapos nasa next line na si 4, next line si 5, next line si 6, and so on. So, hindi ko na siya kailangang i-delete at ilagay sa isang row. Pwede ko na lang siyang lagyan ng end bracket sa dulo, tapos lagyan ko ng apostrophe para ma-prime na siya. So, hindi maarte si Matlab doon sa itsura ng vector. Basta may line, considered yon as another um, as another row in your matrix, and so on. So, yung mga shortcuts na yan, matututunan nyo din yan sooner or later. Alright? Ano pa ba? So yung copy pasting, madali lang siya. Copy paste yung 254 rows, paste nyo dun sa Matlab, tapos ita-transpose nyo nga lang para yung row number maging column number. Medyo tricky and mahirap po sa number 4. Ano yung number 4, Bea? Limutan ko na yung number 4. Actually, dinadaldal ko lang kayo kasi hindi ako
Sir,
makapag-share
yun po
screen.
yung Excel. Yung parang may
Sorry?
data po na ita-download.
Okay, I see. Yun na yung
Historical data po.
kasi ita-plot nyo over. Kasi gusto natin makita gaano kaganda yung approximation pag tiningnan natin yung lahat ng data. Kasi dun sa number 1, dun sa first few problems, gumamit lang tayo ng ilan ba? Siyam na data para ma-model yung what you call this, yung behavior nung prices, ano. So, pag nag-interpolate tayo, lagi siyang daraan doon sa mga data points na ginamit natin because that's the promise of interpolation. It's an approximation technique where if you have n+1 data points, you'll get a polynomial of degree at most and the siguradong daraan doon sa bawat isang mga points doon sa data set. Kaya lang alam natin hindi lang naman yung data na meron tayo, right? So kaya gusto ko ipakita sa inyo ipatingnan sa inyo kung gaano kaganda yung fit niya relative doon sa mga data na hindi natin ginamit doon sa interpolation. All right? So medyo tricky nga yun kasi ang daming data download nyo tapos ipa-plot nyo over. But I hope you didn't have any problems with plotting it kasi pag nag-plot naman kayo, pwedeng meron kang symbolic plot, yung f-plot, tapos yung scatter plot pwede nyo gamitin. Scatter yung command kay Matlab. So if you didn't know what the syntax for scatter plot, you could have searched kahit sa internet or kahit dun sa documentation, yung help dun sa I think it's in the upper right of Matlab. So makikita nyo doon or pwede nyo i-search doon paano nag-scatter plot. Yeah. So sabi ni Brian, hindi sunod-sunod yung dates. Yes, kasi yung prices ay during work days. So walang trading ang Philippine stocks tuwing holidays and tuwing weekends. Kaya medyo, yan. Question ni Elgin ay, sa future Xers, paghingi po yung file, pwede po bang i-attach na lang po yung Excel file kapag ini-import po yung data sa Matlab? Yes, I think you can do that. Ilagay nyo na lang siya sa appendix, ano? So, sige, papayagan ko na lang ng multiple files yung isubmit nyo. Pero make sure you have one PDF file na pwedeng basahin nung mag-check, alright, or your lab instructors. Make sure you have a PDF file wherein you answered everything that is asked for in the lab exercise. If the lab exercise is asking you for an analysis, then if it asks you for something to display, say, the polynomial, then dapat ilagay nyo yun dun sa main PDF file. Anything na hindi tinanong dun sa lab exer, pwedeng nasa appendix na. Or kung ako yung nag-check, hindi ko na nga siya hinahanap. So I just want to see dun sa isasubmit nyo yung mga hinahanap ko talaga. Right? And then, can you guys see my screen now? Or hindi pa rin? I don't know what's happening. I cannot share my screen. Sige, try pa ako ng isa. Huh. I don't know what's happening. Give me one moment. Oh, by the way, yesterday well, sorry about that. Yeah, by the way, kahapon pala, I went to campus and it was nice to see some of you, Um, it's nice to meet you, although honestly, I cannot recognize everybody. Kasi number one, naka-face mask tayo. And then number two, nakikita ko lang dito sa Teams ay mga initials nyo. Yung iba walang pictures. So, halimbawa kay Bea, BL lang yung nakikita ko. Kay Brian, BO lang. Kay Ray, ML lang. So, ang hirap. So, hindi ko talaga na-recognize. But it was nice and I really appreciated it na kayo yung nagpapakilala. Alright? So, na estudyante ko kayo, then siguro next time, better yet, mention your name para maalala ko. Or yung iba kasi sa letters ko lang alam yung pangalan, pumipirma ako sa mga letters nyo. Pero I really don't recognize your faces, ano? But at least I recognize your names, pero yung faces nga yung hindi. And I still can't present. I don't know what's happening this morning. Pero sige. Okay, siguro for now, let's how should I do it? Okay. I'll just use my laptop for the moment because anyway, I'll be going back to our Matlab code just to play with it. So, tingnan natin. Buksan ko na rin yung PDF dito sa aking monitor. No mapag-share from my tablet. So, ayan tuloy. Umiiksi na ng umiiksi yung next excerpt nyo kasi anong oras na hindi pa ako napag-start mag-discuss. Pero gusto niyo naman yun, di ba? Hold on. Saan nga tayo natapos last time? I think we just finished modeling the epidemic curve last time. So maybe I can start there. Okay, good. Okay, there you go. I hope you can see my screen. There we go. So last time, tiningnan natin yung Matlab code on how to implement the Lagrange form for the interpolating polynomial. And we were successful in getting the polynomial, right, using Matlab. So we didn't have to do any hand computation for it. Lalo na kung maliit lang naman yung data or if the data is already in Matlab form, napakadali niya. You just need to edit some lines on the code that I provided you last time, and then hit F5 or press run, and then you're good to go. Tapos pwede natin siyang paglaruan. And this is one, and then here we can see the beauty of using. Kasi sabi ko nga, ang requirement lang sa interpolating sa interpolating function, dapat magpa-pass through siya dun sa lahat ng data points, right? But we used or we started our discussion of interpolating functions in terms of the algebraic interpolating polynomial. And as the name implies, ang nakukuha natin na isang polynomial of a certain degree na dadaan dun sa lahat ng points. Sir, why choose polynomials? Bakit hindi sines at cosines yung ginagamit mo? Bakit hindi rational functions yung ginagamit mo? Bakit hindi exponentials, hindi trigonometrics? Well, it's just a matter of choice because polynomials are, number one, very simple. They're ideal for machine implementations. You see, halos lahat ng ginawa natin last week, kaya nating ipagawa kay Matlab because thankfully, the interpolating function is a polynomial. Right? And then number two, the unisolvence theorem guarantees us na kahit ilan pa yung data points na meron ka, lagi kang merong makikitang polynomial of degree 1 less than the number of points at the most na makakapagbigay sa atin ng na magi-interpolate dun sa given data. So it doesn't matter how complex it is. It doesn't matter how many points you have, you will always find one, and actually not just one, but one and exactly one interpolating polynomial. So pare-parehas tayo na magiging sagot kapag ka interpolating polynomial yung hinanap natin, all right? No matter what programming language or whatever form of the algebraic interpolating polynomial you used. And then on the ubiquity side of things, ang dali ng polynomial, kaya natin siyang ipagawa sa computers, yung function evaluations, they only require arithmetical operations. And then, ang derivative at ang integral ng polynomials ay polynomials pa rin. So we won't have any problem asking our machine to do integration, differentiation for us. And being able to do that will give us the luxury of using technology to apply calculus tools dun sa polynomials na na-consider natin. So halimbawa, dun sa epidemic curve natin last time. So I have my program here. So ito yung data. So basically, ito lang naman yung babaguhin nyo so far. Ano? Pag meron kayong Lagrange form, given yung data. So ito lang yung babaguhin nyo. T would be the abscissas, the x values, and D is your data points, all right, or the function values at the given abscissas. Then once you have this set up, kailangan mo na lang i-run. Tapos it will give us the polynomials, and then it will give you the graph of the polynomial. All right? Now, sabi ko nga, polynomial yan. So, pwede natin itong paglaruan. We can use the tools that we learned from analysis. Halimbawa, gusto kong mahanap kailan nagkaroon ng maximum number of infections and how many were infected during that time. Well, if you have the graph like here, okay, so ang daling tingnan, somewhere nandito, between day 70 and day 80, nangyari yung peak ng epidemic, all right? But if you want to get the particular day number at which nag-occur yung maximum at minimum, kailangan lang nating isipin, ano nga ba yung ginawa ko ng Math36? Kasi ang nag-prevent lang naman sa atin from getting the maximum or the maximizer of the number of infected individuals due to the disease ay kasi yung given lang sa ating information ay discrete data points. Hindi tayo given ng function before. But now we have a polynomial that models the given data. At sabihin natin, ito yung modelo ko para dun sa epidemic. And if somebody asks, kailan nangyari yung pinakamaraming number of infections? Well, pwede kong gamitin yung mga natutunan natin mula sa Math36. Particularly, can somebody remind me paano nga naghahanap ng maximum at saka minimum sa Math36 if you know the polynomial or if you know the function involved? How do I get the maximum of a function using calculus tools? Paano guys? Come on. Or masyado pang maaga para tanungin ko kayo ng calculus, ano?
Ano po? Ay, good morning po, sir.
Good morning.
Kapag po, sir, yung i-equate po natin yung derivative ng isang function at kung ano yung nagsasatisfy na values ng x, yung f of x po nun yung either maximum or minimum po ng isang function.
Okay. Thank you, Nicolette. That's perfect. Ano? Natutunan natin pag meron kang function f, gusto mong makuha yung maximum o minimum value niya, kailangan mo lang kunin yung critical numbers. The critical numbers are those that will make the derivative equal to 0 or undefined. So first step, kailangan natin computein yung derivative at kunin yung roots ng derivative. Those are our candidates for the maximizers and minimizers of our function. Tapos titingnan na lang natin kung nag-work ka sa closed interval, gagamitin mo yung extreme value theorem. Sasabihin kasi ng extreme value theorem kung sino yung sino dun sa mga critical numbers yung may pinakamalaking function value, yun yung absolute max. Kung sino yung may pinakamaliit na function value sa mga critical numbers, siya yung absolute minimum. That is kung nag-work ka sa isang closed interval. Kung open interval naman yan, pwede ka mag-first o kaya second derivative test. Sa second derivative test, kapag positive yung second derivative, meron kang maximum. Pag negative yung second derivative, meron kang minimum. Alright? So those are things that we can do. And luckily, polynomials yan, kayang-kaya ni Matlab yung paggawa ng mga bagay na yon for polynomials. So, no, hindi tayo magko-compute by hand. Though madali lang naman kasi degree 4 lang yung polynomial natin para sa data na to. So what I'll do is this. So nirun ko yung program ko. And if you see here on the left, nasa workspace, nandiyan na yung mga variables. Computed si D, si I, si interpolant, si K. So ngayon, pwede kong gamitin calculator si Matlab. So I'll just go to the command window. Of course, you can include this part in your main code, pero demo ko lang kung gagamitin nyo ay yung command window para pwede kang mag-manipulate line by line. Alright? So, yung sabi ni Nicolette kanina, una, kunin mo yung derivative. So I'll ask Matlab to compute the derivative of the interpolating polynomial p, pero tawagin ko siyang p prime. So si p prime, siya yung derivative ni p. Ang syntax para sa differentiation kay Matlab ay diff. So p prime equals diff. Nasa loob, sino yung gusto mong i-differentiate. So pag I hit enter, so you see here's p prime. Okay? Tapos naka-store na yung polynomial na yan kay p prime. Tapos ang susunod kong, sige, siguro tingnan natin yung itsura niya. Maybe I can write it as, gusto ko makita yung itsura ni p prime na naka-decimal point. So maybe I can use double, then VPA, and then p prime. Para makita natin yung variable precision arithmetic form ni p prime. Oops, ayaw niya na may double. Sobrahin ko yung double. I-VPA ko lang si p prime. Okay, so yan yung itsura ni p prime. Kaya lang naka-nested pa siya, no? Siguro I'll ask VPA ng expand para makita ko yung expanded form ni p prime. Okay, so ito yung itsura ni p prime. So it's a third order. So yan yung derivative ni p. And yeah, yan yung mangyayari. Tapos tapos para makuha yung critical numbers, kailangan ko itong i-equate kay 0. So basically, I want to find the roots of p prime. Sila yung mga critical numbers. Pero paano tayo magpapahanap kay Matlab ng roots ng isang polynomial? Well, medyo weird nga lang yung ginagawa ni Matlab. Kailangan niyang, para makuha yung roots ng isang polynomial, ang input dapat ay vector consisting of the coefficients ng polynomial. So, hindi mo pwedeng i-input dun sa roots command ni Matlab yung buong polynomial na symbolic. Ang kailangang input dun sa paghahanap ng roots kay Matlab ay yung coefficients ng polynomial. So, how do we do that? Well, here's the code. So, kukunin ko yung coefficients ni p prime and I will store it in the variable coef. All right? So, coef equals, ito yung syntax para i-harvest yung mga coefficients ng polynomial p prime. So sim 2 poly, all right? SYM number 2 and then poly. Tapos ilagay nyo ano yung polynomial na gusto nyong i-harvest yung kanyang mga coefficients. So here I want to harvest the coefficients of p prime. So there you go. I'll type sim to poly of p prime, then I'll get this. Ito si coef. So ito yung coefficients nung polynomials. So negative 0.0089 being the first entry of the vector coef, meaning ito yung coefficient ng highest power ni x doon sa polynomial. Remember, p prime is of degree 3. So mauna, coefficient ni x cubed, coefficient ni x squared, coefficient ni x, tapos yung constant. Right? So that's what sim to poly does. It will translate a polynomial into a vector of coefficients with the ordering is in decreasing order of degree or decreasing degree yung order ng entries ni coefficient. Pag na-harvest mo na yung coefficient matrix, yung coefficient vector, pwede mo na lang tawagin yung roots. Tawagin ko yung tawagin ko CN, yung mga roots ng p prime. CN for critical number. Para mahanap sila, kukunin ko yung roots ng p prime. Kay Matlab, ang syntax ng paghahanap ng roots ng isang polynomial ay roots. Tapos, ang input niya ay yung coefficient vector. Alright, so ito yung coef. Yung vector na ang laman ay mga coefficients noong polynomial. And then hit enter, it will give you the critical numbers. So critical numbers ay 73, negative 28, and 5.0918. Okay, we will learn later that the validity of the interpolating polynomial, and probably you have seen this in the exercise, ay mula lang dun sa pinakamaliit na abscissa. We'll talk about that more as we finish module number 2. Pero putting that at the back of our minds, okay, nagma-maximum at nagmi-minimum lang pala ako from the smallest value of the abscissa up to the highest value of the abscissa. Remember here our data our numbers are these 5 numbers, right? 0, 10, 25, 50, and 100. So ibig sabihin, valid lang yung interpolation ko from 0 to 100. It's a closed interval. So pwede kong gamitin yung extreme value theorem on the closed interval 0 to 100. The extreme value theorem guarantees the existence of an absolute maximum over the given interval. And moreover, the maximum and the minimum value will occur at one of the critical points or the critical numbers. Alam na natin yung tatlong critical numbers, 73.7115, negative 28.0290, and 5.0918. Para malaman sino sa kanila yung absolute max at absolute min, palakihan lang sila ng function value. And remember how we do function value evaluation? Pwede kong gawin yung double. One nice thing about Matlab nga pala, pwedeng type mo lang kung alam mo na run mo na before yung command, pwedeng i-type mo na lang yung that you have yeah, there you go. Papakita niya yung mga similar commands that you have run before, right? So hopefully I'm still here. Tumigil yung internet ko sa laptop earlier, pero parang nag-move pa naman siya sa second monitor ko. So I think it's good. So here I want to substitute papunta kay P, pero hindi na ngayon ang sa substitute ko sa kanya ngayon ay yung mga critical numbers, right? So remember, this is the syntax for evaluating function values. So naka-double para naka-decimal point yung ibibigay niyang answer. Pag hindi nyo dinoble yan, ang ibibigay niya ay fraction. It makes sense for us to talk about decimal digits now, right? Tapos subs, ito yung command sa pagsa-substitute. Tapos first input kay subs, saan ka magsa-substitute? Remember, ginagawa ko ngayon, palakihan na lang ng function value yung mga critical numbers. So I will substitute the critical numbers into P. Alright? So P, tapos ano yung isa-substitute kay P? Yung mga entries ni CN, yung mga critical numbers. And then I hit enter. Oops, what happened? Hit enter. There we go. So ito yung sagot. Just make sure, minsan kasi si Matlab nagfa-factor ng order of magnitude para maganda yung display niya. Ang default display niya kasi ay significant digits. All right. So here, everything, all the entries in this vector is multiplied by 10 to the fourth. All right. So that means the highest ay yung unang entry nung substitution, which came from the first critical number. So that means the maximum number of infected individuals is 3.2131 times 10 to the fourth power, and it occurred at day number 73.7115. And that means, because if you go back to our graph, it's 20 and day 80. All right. And yeah, you can say, yeah, it makes sense. It's 73.7115. And then the minimum number of casualties now doesn't make any sense. Kasi dun sa critical numbers natin ay ito, 0.435 na, 0.4352 times 10 to the fourth. Yan yung sumunod na pinakamaliit na positive number, but that happened at x equals negative 28.0290 outside of the interpolation interval. We cannot trust that result. And then, anyway, if 28 because x of days for that and 6 nominal mo natin. Then the other candidate is to give us the minimum is day 5.0918, but the value it gave us doesn't make any sense also because we're talking about the number of infected individuals. At ang function value ng 5.09 ay negative 0.02 times 10 to the fourth, and it doesn't make any sense, all right? Kasi negative number of individuals, wala tayong interpretation for that. Okay? But I hope you see now the power that this gives us, yung modeling power na binibigay sa atin ito. Though meron siyang limitations kasi polynomials are not always the best model for a certain phenomenon, ano? Pero at least using this tool, meron tayong nakuhang idea about our function and about yung VPA. All right, so VPA of P, ba, ipapa-VPA ko si P, i-display niya lang i-display niya lamang yung polynomial p na ang mga coefficients ay naka-variable precision arithmetic, right? Or nagpa-follow ng variable precision arithmetic. To see it, ano ba si P? Si P muna, ito yung itsura niya. Naka-fraction siya, right? So naka-fraction si P, kasi nga symbolic variable si P, Matlab will do its best to keep all calculations exact. Kasi sabi natin, symbolic calculation to, dapat eksakto lahat ng sagot mo. Huwag kang mag-round off as much as you can. Yun yung ginagawa ni Matlab pag symbolic yung variable. So if you go to your workspace, si P rito ay nakadeclare, makikita niyo yung data type. So P is 1/1 sim. Ibig sabihin, it's a 1/1 symbolic variable. Okay? So, numerical calculations ay hindi natin pwedeng gawin kay P kasi symbolic na klase siya ng variable. Okay. Now, if you want to see this or the result in, say, naka-decimal point sila with maximum precision, you can ask Matlab to do VPA. VPA of P will give us this. Naka-display siya in the variable precision form. Ibig sabihin kung ano bang default ni Matlab? I think 16. 16 ba to or even more? So, ibibigay niya yung value ng mga fractions in as much precision as possible. Alright? So, naka-fraction siya. Kaya lang, eto si ANS, di ba? Yung pala, pag nagpa-compute ka sa command window, tapos hindi mo siya inassign sa isang variable, katulad nito, pinakompute ko lang sa kanya si VPA of P. Pero hindi ko inassign sa isang variable handle, masisave dun sa workspace. Kasi hindi ko siya binigyan ng pangalan. Pero by default, pag nagpapasolve ka kay Matlab, yung previous result, yung pinakahuli niyang kinompute, nilalagay niya sa variable na ans. Short for answer. Okay? So titingnan mo, pag nag-VPA ako, anong klase yung, well, pero the workspace, tingnan niyo si ans. Si ans, ang type niya pa rin ay 1/1 symbolic variable. So ibig sabihin, pag nag-VPA ka, symbolic pa rin. Now, if you want to work around this, guys, kapag ka hindi nag-accept ng symbolic expression yung isang Matlab command, kailangan mo siyang i-convert into double precision. Okay. So, yun yung ginagawa ng double. Double, tapos i-input ko si P. Oops. Kailangan mo na siyang i-VPA. Ba? VPA. Ano yung ginawa natin dati na may double? Kailangan ko munang mag-substitute. Siguro dito, substitute ko halimbawa si X. Ayaw niya talaga. Pero ang gagawin ni double ay gagawin niya itong i-convert niya, yung double, nagko-convert siya from symbolic to usual numbers or usual vectors. So hindi na siya symbolic variable, magiging numerical variable na yung magiging ng P, tapos sinubstitute mo yung mga critical numbers. Tingnan natin. Subs ng P, critical number. So, ang ilalabas niya ay symbolic variable pa rin. Kasi tingnan yung ans. Yung ans ay 3/1 symbolic variable pa rin. So, ibig sabihin, ang laman ng vector nito ay mga symbolic expressions. Mga eksaktong expressions. Kaya sila naka-fractions. Pag VPA natin yung answer, i-display niya yung mga numbers na naka-decimal point. Pero if you go to the workspace, ang variable type pa rin ni ans ay 3/1 symbolic variable. So, hindi ko pa ito ma-manipulate using numerical tools. Right? Pag gusto mo talaga na makuha na yung ma-convert siya, gamitin mo yung double, tapos ans. Pumunta ka na sa sasabihin na it's a symbolic variable. Okay? So, yan. Pwede mo na itong paglaruan as if they are really numbers. Yun yung kaibahan. Kasi sa VBA, hindi siya, okay? So I hope that differentiates VPA and double kung kailan sila nag-work at hindi. Sorry, medyo nag-lag daw ako doon. Any question? Oh, sorry about that, Mitzi. Yeah, prime time kasi that is my internet connection. Pero any point that you want na ulitin ko? Ano yung hindi clear? Or lahat? Hello, guys. Aling part yung hindi malinaw dahil sa pagiging choppy? Or sa sobrang choppy, wala kayong naintindihan simula umpisa? Okay, right. Okay, so that's what I'm afraid of. Sana mas clear na ngayon. 4 bars na naman daw yung internet ko. So yeah, no worries, Mary. Yeah, it's my fault. Yeah, tama yung summary ni Christian dun sa chat. Kapag ka VPA, alright, pag VPA yung ginamit nyo, i-display niya pa rin i-display niya in decimal representation yung output nyo. Pero symbolic variable pa rin siya. Okay, symbolic variable pa rin. Yung variable type niya ay symbolic. Kapag ka double, kino-convert niya yung symbolic variable papunta dun sa numeric number na siya. Right? So, yun yung basically yung difference nilang dalawa. Kanina nagbigay ako ng maraming examples, yun siguro yung nagputol-putol ako. No? Pero thank you, Christian, for the nice summary of the difference between the two. Kasi minsan, may mga commands si Matlab na tinatanggap lang niya na input ay symbolic variables. Halimbawa, yung derivative. Yung diff of p, okay, symbolic variable lang yung yung ina-accept niya na argument. Kasi how can you differentiate a number? It will just be zero, right? So kapag meron kang constant, differentiate mo siya, ang sagot lang ay zero. So ang i-accept lang ni diff ay symbolic variables. Tapos, meron din naman ng tinatanggap lang ay mga numeric variables, ano? So, like roots. Magpapakompute ako ng roots ni polynomial p. Okay? It doesn't make sense kasi nga ang input dapat kay roots, okay? Or ang input dapat dun sa command na roots ay isang vector consisting of numerical coefficients. Kaya hindi nag-work yung roots. Kaya makikita nyo dito, ang sagot niya sa roots of p ay empty, symbolic variable 0 by 1. Kasi nga, ang ina-accept lang ng roots ay mga numeric variables. Okay. So, to make sense, so ang gagawin ko kay roots, ang i-input ko sa kanya ay yung coefficients ni polynomial p. Okay. Ang syntax pagkuha ng numerical coefficients ng isang polynomial p ay sim to poly. Tapos siya yung i-input ko sa roots. Ito ko yung makukuha kong roots nung oops, ba't wala? Ayan. Ito yung makukuha kong roots ng ating polynomial p. In terms of computations, Elgin, ang pinagkaiba lang nila ay paano siya i-handle ni Matlab. Okay? Parehas lang yung method, pero sa symbolic variables, limited yung mga pwede nating ipagawa kay Matlab. May mga commands kay Matlab na symbolic lang yung tinatanggap niya. May mga commands na numerical variable lang yung ina-accept niya. Meron din naman na ina-accept niya both. To be very careful. You can do trial and error. Pag may nirarun ka, sasabihin naman ni Matlab na hindi match yung variable type na pinasa mo sa akin. Okay. Pero I suggest sa dulo na lang kayo mag-double. Kasi pagka symbolic variable, tinatry niya to be exact as possible. Hindi siya nagtra-truncate as much as possible. Mag-work siya using fractions, all right? Para eksakto yung makuha niya sagot. Hindi siya nagta-truncate into a given precision. Pagka double kasi double precision na lang siya, magka-cut siya sa floating point arithmetic, medyo may artifacts na yung makukuha mo na solution. Alright? So parang ngayon pala yung introduction tayo sa Matlab, ano? I don't mind. Okay naman yung ganito, no? Okay, so yeah, you can try this example, the pricing problem, ano? So try to do it using the Matlab code I provided to you and the discussion we have today. Dun sa pricing problem, ang problema ng merchant, gusto niyang malaman kung gaano niya or kung magkano niya ibebenta yung kanyang product to get the maximum revenue. Okay. So remember dun sa introduction, dun sa module number 2, meron na tayo dong table ng selling price at saka demand. Let me go back there. Okay. So nandito sa page 5, ito yung ilan yung mabebenta ko kapag binenta ko siya ng 70 pesos. I'll be able to sell 1,250 units and so on. Right? So ito yung data. Ang problem dun sa susunod na example ay magkano ko siya dapat ibenta para makakuha ko ng pinakamalaking revenue. Alright? So you need to do a little bit of modeling before we come up with the actual thing na gagamitan natin ng calculus. Una, kailangan ko muna magkaroon ng model kung ilang units yung mabebenta ko. Right? And that's easy. You just need to input this, guys. Tingnan ko kung makaka-copy-paste ko. Anyway, hindi ko na naman masisimulan yung next section. No? So copy-paste ko siya sa T. Tingnan ko kung ano yung itsura niya pag pinis ko siya. Okay, good. Kinopy-paste ko siya mula dun sa PDF. Nag-work naman 70 hanggang 187.5. I'll do the same thing for the number of products sold. Copy-paste, papunta rito. Okay. Now, sorry, may decimal point pala ako nilagay. Tanggal natin yung decimal, yung comma, all right? So these are my new data, and then if I run the same code that we have, magkakaroon tayo ng model para dun sa ilan yung nabebenta for the demand function, right? So okay. So baguhin ko lang yung Y label kasi, saka yung X label. Gawin ko tong price para maganda yung itsura ng graph. Tapos ito naman yung number of products sold. Okay. Hit F5. Okay. So ito ngayon yung makukuha natin na model para dun sa ilan yung nabebenta ko. Right? And you can check the interpolatory requirement at 70 pesos, 1,250 yung nabenta ko. At 82.50, 750 pieces yung nabenta ko. So it will really pass through all of those given points. So this is our model for the demand for the commodity, you know. So if you want to know how many units will I be able to sell if I will impose the price, say ano nga yung data natin? Ano ba, gusto ko ibenta siya, say how many pieces of the product will I be able to sold? So you'll just need to do subs, tapos kay polynomial p, siya yung interpolant natin. Isa-substitute ko ay si 100. Then this is my price. This is a symbolic variable. So pag nag-VPA ka dun sa ANS, bibigay pa rin niya ay symbolic. 1463. So ibig sabihin, if the price is 100 pesos, I'll be able to sell around 426 units, right? So, kaya lang naka-symbolic yan. Kung kailangan ko ng numerical answer, gamitin ko lang yung double of ANS, I'll get this. Tapos isa na siyang numeric variable. So, 426 yung masisell ko na product. Okay? Pero dun sa pricing problem natin, yung next example, ang tanong ni merchant ay magkano ko siya dapat ibenta para mahanap ko yung maximum revenue. Hindi siya yung polynomial na nakuha natin because it models the demand. Gusto ko malaman magkano pera yung makukuha ko kapag binenta ko siya ng ganitong presyo, right? I know the demand, which is the polynomial P. Hanapin ko ngayon magkano yung revenue. But the revenue is just the number of products sold times the selling price. So, ibig sabihin yung revenue function natin, tawagin nating R, okay, ay equal lamang sa X, which is the price, times the demand, which is our polynomial P. So ito na ngayon yung ating model for the revenue, right? x times the demand function, or in the parlance ni Matlab, x times p lang siya. Gusto ko mahanap gaano yung maximum, ano yung optimal selling price. So kunin ko dapat yung critical numbers. So what I want to do, pwede kong isang bagsakan lang siya gawin. Kaninang example, inisa-isa ko siya kanina. Ngayon, gusto kong kunin dire-diretso na. Gusto kong kunin yung roots ng derivative, right? So I will differentiate si P, not P, pero si R, yung revenue function, kasi siya yung gusto kong kunin ng maximum, right? So i-differentiate ko si R, pero makukuha ko dito ay isang polynomial na naman at isa yung symbolic variable. Para magamit ko yung roots na panghanap ng root ng polynomial, kailangan kong kunin yung coefficients nung derivative ni R. Remember, yung pagkuha ng coefficients ng isang polynomial ay sim to poly. Nasa loob niya yung derivative ni R. Now, the result under sim to poly ay isang numerical vector. Vector siya ng mga numerical coefficients, which is an accepted input para dun sa roots command. Right? Sabihin, ito yung roots. So, ibig sabihin, ito yung critical numbers. Ito yung mga candidates para magbigay sa atin ng maximum revenue. 164 pesos, 105 pesos, and 33 pesos. Now, to make sure which one of them, remember, say, mag-work lang ako sa closed interval na 70 to 187.50. Magagamit ko na naman yung extreme value theorem. Sabi ng extreme value theorem, palakihan lamang itong tatlong critical numbers ito ng function value. So what I'll do is I'll substitute this roots. Lagay ko ulit sa vector na critical number yung mga na-compute natin na critical numbers. Kasi hindi siya nakasave. So save ko lang siya sa variable na cn, tapos palakihan ng function value. So I will just i-double ko na, tapos isa-substitute ko kay R, kasi ang minamaximize natin ay revenue, yung mga critical numbers na na-compute natin. And these are the respective values. So this is values to ng revenue. So this would be 10 to the 5th power times this, guys. Ang pinakamalaki ay 1.5260. So that would be our maximum revenue. The maximum revenue is 1.5260 times 10 to the 5th. And we can get that by using the third critical number, which is 33. Parang malito. 33.3659. Let's see. Parang 164 dapat yung makuha ko. Anyway. Oh, bakit ko pala to i-discard? Kasi sabi dun sa example natin, ang sagot ay 164.2. Kaya lang nung nag-compute ako, ang sabi ang maximum mangyayari kay 33.3659. Why did I say in the module na hindi pwedeng si 33.3659 yung sabihin ko na selling price, na optimal selling price? Okay, Ray is correct. Thank you, Ray. Yeah, and then Nicolette is also right. Nasa labas kasi ng range ng abscissas yung 33.3659 kasi nga dun sa end ng module 2 na akala ko ay madidiscuss natin today, ang haba na naman ng mga pinagsasabi ko, ay magiging valid lang yung model mula dun sa pinakamaliit na abscissa papunta dun sa pinakamalaking abscissa. The smallest x value that we have for this problem is 70 pesos. The largest is 187.50. So our interpolating polynomial is valid only on the closed interval 70 to 187.5. Any value that we get outside of these abscissas or we use outside of this range ay hindi natin pwedeng pagkatiwalaan yung ating model. Kasi yung model ay valid lang from 70 to 187.50. So, X na si 33.3659. Out of the running na siya. So, our only candidates left for the best selling price would be 164 and change and 105 and change. Sa kanilang dalawa, mas malaki yung function value ni 164.20. So, kung meron kang business, naggawa ka ng experiment, nakakuha ka ng 5 data, tapos nalaman mo magkano yung kaya mong ibenta sa bawat selling price. Now, using this model, you could compute magkano ko siya dapat ibebenta. And sabi ng model, dapat ibenta mo siya ng 164 pesos and 20 cents para makuha mo yung maximum revenue. Okay? Now, yeah. So, ibig sabihin, what do you say? What do you call this? Sa Thursday, time na kagad, pupuntahan ko si example 2.6 ng mabilisan, and then promise, tatapusin ko na yung section C. Alright? So that means, anong gagawin niyo sa Monday? Sige, maiksi lang yung exercise sa Monday. It will just out section C. Ano? Sige, babawasan ko na talaga yung kwento next time para mahal haba-haba yung ating mako-cover, ano. Pero that's how I run my lectures, ano. Hindi ako conscious masyado na sundin yung course guide. Kasi mas okay na maintindihan natin yung concepts in a deep enough level kaysa ang dami nating makover tapos puro shallow lang naman yung naintindihan natin. And I think this is a good familiarization also with Matlab. So I think it's worth it. So kahit na siguro good for 1 hour lang yung extra nyo on Monday, so that would be good. All right? So any questions or comments? Again, those who participated in the verbal discussion, kindly put a comment in the chat para malaman ko lang. Sige, Neil, kasama ka na kasi ikaw lang naman yung nag-share substantially ng experience mo. At ikaw lang ba? And then anybody else that talk during the class, so you can put a comment on the chat box so I know that you recited. I see Nicolette raising her hand. Tama ba?
Yes, gusto may tanong po sana.
Yeah, go ahead.
Sa pag-identify po sir ng critical points, hindi po ba hindi po namin isasama yung dulo po ng interval. For example po, yung interval is A, B. Hindi na po namin i-evaluate yung A tsaka B para maging potential maximum.
Oh yeah, right. Thank you, Nicolette, for reminding me about that. Yun nga pala yung sabi ng extreme value theorem, ano? So nakalimutan ko pala siyang i-consider. Kasi aside from the critical numbers nga pala, thank you for reminding me. Aside from the critical numbers, posible rin nga palang magbigay ng maximum o minimum yung endpoints. Alright? So, pwede kong gawin. So, hindi pa pala final na 164.20. Kailangan ko pang i-make sure na mas malaki yung ibibigay na revenue ni 164.2 kaysa kay 70 at 187.50. So para magawa yon, so gawin lang natin yung subs, tapos i-double ko na siya, tapos subs ako kay R nung endpoints. Pero dapat naka-vector. Naka-vector lagi yung isa-substitute nyo kay R. So isa-substitute ko yung endpoints which are 70 and 187.50. Oops, 187.50. And bracket para dun sa vector ng pang-substitute. Then close parenthesis. Okay. Okay. So this is 10 to the 4th times these two guys. So it's 8.75 times 10 to the 4th and 5.10 times 10 to the 4th. Both are smaller than 1.50. Then 1.07 times 10 to the 5th. So nanalo pa rin ay si 164.2 kasi mas malaki yung revenue against the endpoints, 70 and 187.50. Oh, thank you for that. That's a crucial thing that I forgot. Pero yeah, sa XOR, kailangan nyo yung i-check kasi baka doon lumabas yung maximum or minimum. May good question si Ned. Good idea ba na gawin yung computations na to sa command window? Well, usually I don't recommend just using the command window. Ginawa ko lang siya ngayon para i-illustrate na pwede mo siyang gawin. Alright, on the command window. Yun ay kapag ka nagawa mo na yung mahabang computations before. So you're working as if you are in a calculator. Pero kung sa tingin mo gagamitin mo to over and over again, you can embed those things typed in the command window into the main program. Same lang naman yung syntax. Kung ano yung tinype ko sa command window, yun yung i-copy paste nyo rin sa editor. Yun nga lang kasi hindi ko naman siguro kailangan laging nagko-compute ng critical numbers kapag nagkukuha ko ng interpolating polynomial. Kaya yun yung isang reason kaya kung bakit hindi ko rin to in-embed. Kasi hindi ko naman to kailangan gawin para sa lahat ng interpolation problems. It's just an ad hoc computation. Pero if you think you'll need it over and over again, lagay mo siya dun sa main program. Ang isa niya nga lang con ay kapag iba-iba yung pag in-embed mo kasi siya dun sa main program, kailangan mong i-run yung entire program over and over again para lang mag-compute halimbawa ng derivative. Alright? So, mauulit, magiging redundant yung computations. Kaya doon ko lang siya ginawa sa command window. Pero yon, usually mas okay na ilagay siya doon sa code. Unless super ad hoc lang ng computations na gagawin mo na hindi mo kailangang i-rerun yung buong part ng code. Right? I hope that makes sense. Other questions? Sorry, overtime na naman pala ako. So, but anyway, if you guys have classes, pwede kayong umalis 10 minutes before before the end of the class, ano? And then you can just watch the recording later kung medyo nag-extend ako ng konti. Other concerns or questions? Okay, so if none, promise talaga sa Thursday tatapusin ko na yung module 2 para next week makapag-start na tayo ng module 3. Alright? But module 3 is already available in Canva, so you can do reading, advanced reading. Alright? So if there are no more things that you want to talk about, so thank you guys for joining me. Apologies for the lag and for the overtime. Pero yeah, thank you for bearing with me. Let's see each other again on Thursday. All right? Bye, guys.
Yes, sir.
Thank you po, sir.
All right.
Thank you
You're
po,
all
sir.
welcome.